Okay, g'day, I'm Joe from Professional CAD Systems. Today we're going to show you how to reverse engineer this motorcycle part. So it's a very complex shape, nearly impossible to measure with traditional measuring techniques. So we've got Creaform's MetraSCAN, and we're going to show you how to get up and running. So the first thing I need to do before we get started is acquire the targets that I've put on the table, and that will ensure that if this table moves in any way, it's tracking the movement of the part. So we go out into the software, I can go and select manual detect, and I just simply drag a selection around those targets and accept it. And you can see it's already registered the targets, they're in red. It's already tracking the MetraSCAN. You can see it on the picture. The C-Track's taking track of that. So then next what I need to do is I need to determine what resolution I need to use to capture the part. So I can go over to the left hand side and I can change the resolution maybe to about 0.8. And what's cool with our software is that we can also adjust like some settings before even getting started. So I can click on auto decimate, and we'll put large triangles in the large surface areas and keep small triangles in the small or the high detailed areas. And we also have a thing called smart resolution. So what it will do is just put small triangles on the high detailed areas and use bigger triangles in the larger surface areas. So next what I'm going to do is hit scan. Cool. And then I just need to capture a little bit of the table because I basically want to remove that. So just simply scan a bit of that. Just enough so I can create a clipping plane. So next I can go add a clipping plane and just delete that out, because I just don't need it. The next step is I need to adjust my shutter speed for the laser strength for the part. So I've got these multi-function buttons on the back of the scanner. I can hold the tick down, scroll down to auto adjust, accept that, aim it at the object, and it will automatically adjust to suit. Once it's done, it will exit. And so at this point, I'm ready to start scanning. So I can hold the trigger down on the front of it. That will start the session. And then tap one more time, and we'll start to collect it. So it's just like 3D spray painting. As I go over and over it, it just keeps filling in the gaps. What's quite nice is it has like a distance meter on the lasers on the screen. So if I get too close, it will go red. Too far away, it will go blue. So you're just aiming to be in the green zone. But it's a very fast scanner. You can just sweep over and over the part as many times as you like, and it will only ever create a single surface. If your laser strength isn't quite enough, you can toggle between zooming in and shutter speed. So I can just increase that a little bit more. And then I should be able to capture the surfaces a bit easier now. That's better. So we'll just go around, make sure we haven't missed anywhere. What's also quite nice with the Black Elite model is that we get a single laser. So if I double tap the trigger, it'll go down to a single line. And it just makes it a little bit easier getting into those hard to reach areas. Plug in there. you can just flick back to the other laser mode. Okay, so that's one half done. We can hold the trigger down and press stop. Then what you need to do to add the second half is we just click on add a scan, and we can copy the clipping objects. So we'll copy that clipping plane that we created, and then we can use that. So it also copies the mesh, so I might delete that. Hit scan again, and now we just need to turn the part over. Okay, so when you're ready to scan the other half, again you just hold the trigger down, tap the trigger one more time, and just start scanning again. And again, I can double tap the trigger just to get into the hard to reach areas. It just gets deep into the holes. So basically it switches to a single lens when you go to the single laser mode. Good. So once you're done, you just hold the trigger again, stop the scan, and now we can look at merging the two scans together. So we can go up to merge scan, and we can do a best fit alignment, and we can just click keep the original scans just in case you want them, and we can click best fit automatic alignment, and it should find enough common geometry that it knows the overlapping data. And at this point, you're not stuck to using 0.8mm triangles. You can actually increase the resolution even further if you wanted to. So I could say maybe like 0.6. And it will recalculate, redraw on the raw information and reproduce an STL mesh based on that data that we've got in the background. So now if we turn off scan 2 and scan 1, you can see we're left with that part. If I get the select tool, I can select all I want to keep because there's a little bit of floating data somewhere, like here. So I select what I want to keep, click on the keep selected delete tool. So keep what you've selected, and it will filter out anything else. And once you're happy, you just click on finalize. And it's just going through and adding in those post or pre-processes that we put in place, the decimate triangles, any hole filling in and stuff like that. And there's the finished result. So when you're happy with your information, all you need to do is export to mesh. So we just go File, Export, Mesh. And then I also like to save the session because that contains all that raw information if you ever want to change the resolution, add more detail. And then lastly, before we stop the scan, I'll just show you how it looks, how the triangles are formulated, how they're all stacked together. So you can see the details that we're getting here. If I go to there, I can go triangles on wireframe, and you can see there's the larger triangles. And on the smaller or sharper edges, you can see it's got more triangles, more density. So it really optimizes the mesh for you to export and use for reverse engineering. Okay, so now that we've finished 3D scanning the motorcycle part, we can now look at VXmodel. So I always like to start a new session, that way you kind of like leave the scan session data behind and it will essentially make a smaller file for VXmodel. So we go to VXmodel in the start menu, then we click on browse and just go and find the STL file that we exported from VXElements. And it will come in just as a mesh, and you can see that it's only VXmodel that's showing, no other scan data. And like I said, it's going to be a smaller file when we hit save. You'll also notice a completely different interface. So VXmodel's toolbars are activated once you go into VXmodel, and it's a module that works inside of VXElements. So the very first thing I like to do is do an alignment. So we need to create some entities to help us do that alignment. So I click on add a plane, and typically it will put you into the correct selection tool for the job. So if I hold Control and click on the plane here, you see it automatically finds whatever is a plane and gives you basically some feedback on how well it's fitted. You can change the area distribution if you want to just check and see if it's within 0.1 of a mil, for example. That's doable, and we can go OK. Next, what I want to do is create a cylinder. So I'm going to click on cylinder here. I'm going to hold Control and click on the cylinder, and you can see it's gone ahead and selected that. And again, I can change my area distribution just to see how well it's fitted. Looks pretty good. But then in addition to that, I can expand the parameters and the constraints, and I can change the length of it because I want to overextend this to basically cut it away from the main body eventually. So I'm going to go 35 millimeters for the length of it, so you can see it's overextended. And for the diameter, if you're reverse engineering this part, you may want to say that that's actually 20 millimeters, a nice round number. Okay, and we can go OK. So let's do another cylinder, and we'll do it on this one over here. So I'm going to hold Control again and click, and just increase the selection tolerances. And you can see it's looking pretty wonky, and partially because I've still got the same size 20mm diameter selected, so that didn't help, so we uncheck that. And I need to go through and select through it as well, because I've got a bit of the cylinder on both sides. So you can see that that's now selecting through nicely, and sometimes I switch to like the brush mode and just pick up a little bit more data there, just so it selects well. Okay, and then I can set the diameter to 7 mil. Okay, and I don't mind that it's overextending itself, that's perfectly fine. So we can go OK and cancel because we're happy with the cylinders that we have. Next, what I need to do is the alignment. So you go to manual alignment, choose the plane 1 as X and Z. I'm going to use cylinder 1 as my Y-axis, and I'm going to use cylinder 2 as my either X or Z axis. It doesn't matter too much, but you'll know what you want to do. And then OK. So then once that's done, we can now extract these other mounting points. So I need to create some planes, and I'm just going to hold Control and click on those planes. OK, hold Control, click, and just keep holding Control and click a few more times, or you can increase the selection tolerance just to select a little bit more, and then OK, hold Control, click, OK. Now you don't have to cancel the menu, you can just go straight to Circle Tool, and then I'm going to select my second plane as my constraining plane. I'm already in the right selection tool, but I might just increase the selection tolerance a little bit, and then hold Control and click on that internal cylinder, and then again I can set the diameter and we'll make that 7mm as well, and then press OK. Switch to the next plane, plane 3,
hold Control and click on the circle on the inside, and you can see it's completely off now because the diameter is obviously different. So you uncheck the diameter, recheck it, and set it to 5, and then OK. Switch to the next plane, plane 4, hold Control and click, and looks a bit funny, so just need to make sure that I have the right plane selected. Plane 2. Okay, and I'm just going to deselect and just try that selection again. Oh, I've already done this one, sorry. Got myself confused. So I go to plane 4, deselect the triangles, and just go ahead and click on the correct hole. That's better and makes more sense. Okay, so we now have those mounting points. We can now remove basically these internal holes because we need to just make a solid body out of the shape, and we want to give it cleaner machinable surfaces. So first I'm going to create a plane and just add that there. Okay, and then select OK. And we can go now to cut plane, and I can select plane number 5. And we're just going to bring that back. It may cut this plane as well, I don't know. No, it's at a different height. So this is just an individual cut. So we're going to not keep both parts. We're going to flip the normal so that it points downwards, and we're going to cut it down 1 millimeter. Alright, and I don't want to fill the cut plane. We're just going to cut only. Okay, so we've done that. And then also what we can do is we can now delete the circle here. So I can get the selection tool and just select that and just get rid of that there, including that cylinder there. Because essentially, you know, we just basically already have a cylinder that we can now remove from the solid body that we're going to create. While we're working on it, I might as well just hit hole fill and just flat hole fill this hole here. Okay, that's good. Okay, we now need to cut the next faces, so we go cut again. I'm going to select plane 2, and again we just adjust the cutting plane, make it smaller so we don't cut anything else apart from the surface that we want to cut. Flip the normal, don't keep both parts, 1 millimeter cut. And then lastly, we're going to do both of these planes. They actually look like they're at the same height. So if that's the case, we might even just be able to create like one plane going across both sides and just increase the selection. So yeah, this obviously was meant to be on the same plane. So we can now go OK, cancel. And then technically we might even be able to go to those previous circles, like circle 2 here, and right click and edit, and just change that constraining plane to the last plane. So I want them to both share plane 6 for CAD, and then edit circle 3, and we want it to share plane 6. Okay. Now that the holes have been sorted, we can now go cut. Use plane 6. Again, don't want to keep both parts, and we want to cut through only the highest point there and nothing else. Flip the normal, increase the offset 1 millimeter, and then preview. Okay. So now, why don't we just show only the mesh for a moment. So right click, show only, selected. And I'm going to use the Connect Selection tool, hold Control and click on what I want to keep. Then I'm going to click on the inverse selection and just delete these holes now because we've already extracted that info. And then delete. Then we can bring back the planes that we need. So we wanted plane 6, we want 5, and then I think it's 2 that we want. Yep. So those 3 planes we want to see because we need to now extrude these boundaries up using that plane. So we're going to go now to extrude boundary. I'm going to select the boundary, and I want to say which plane that I'm going to use. So it's going to be plane 5, and we're going to do it by 1mm more. So we're going to go even further than the original plane was, because we're going to cut it off and make a sharp cut in SolidWorks. Now we're going to do the same for the next boundary, and I believe that was plane 2. Apply, and then plane 6, and then choose which boundaries. Oh, we're going to do one by one, so we'll just go apply, and then choose 6 again, and apply. Okay, so now we can go hole fill, and just flat hole fill, and just click on each of these holes. Okay, and just fill them in. So that's looking good. We'll just leave these ones over here. I think that would be fine. We could attempt to try and make that plane a nice machine plane, but it might get a little bit tricky where it just blends into here, so we might just leave that for now. Okay, so once we've done that, we can now go to clean mesh and just check and see if there's any like irregularities with the mesh, and hit apply, and we'll just fix anything that may be wrong with it, and OK. And lastly, what we can do is we can shrink wrap NURB or CAD surfaces around the scan data. So we have a tool called the Auto Surface tool, and I'm going to set that to about let's say 8,000 pitches and full control points, and let's just go preview. So I'll just pause for this part just to save some time. Okay, so the auto surface is finished, and we can compare the scan data to the auto surface just to see, you know, how accurately it's fitted. If I just turn off the, well, no, that's fine for now. And you can again under, well, we can change the way that it colors, but we'll do that next. So we'll go OK. Okay, so now that it's created, we can go compare to auto surface, and just turn the visibility of the auto surface off for a moment, and then we can set our tolerances. So you might say, okay, I want to make sure that it's within 5 micron or 50 micron. So it's all green there, so we'll try 0.5. So you can see it's still very, very accurately fitted. So let's say 10 micron. And if you want to do any checks, you can do little annotations just to see how closely fitting that auto surface is. So it's just the fastest and easiest way to get to basically a CAD surface for use in SolidWorks. So once we're happy with that, we can now start transferring all of our entities over to SolidWorks. So just turn on everything. Some of these planes I don't actually need, so I think plane 3 and 4 we don't need, because we started to use 6. So I'll just select what entities I need to transfer over to SolidWorks. So I've selected those, and just click on transfer. Okay, so that's done. And they just come through as actual cylinders in SolidWorks and circles. So next we go back to VXmodel, click on the auto surface, and this takes a bit more time, so again I'll probably pause the video just for the time's sake, and click transfer to SolidWorks. But just so you know, you can also transfer to Inventor and Solid Edge. Okay, so we've successfully imported or transferred our auto surface into SolidWorks. So we're now going to just cut away the cylinders and create those machine surfaces. So first we'll select on plane number 2, and I'm going to go and get my sketch tools and just do a little rectangle. And once that's done, I could just jump back into that sketch, just extrude that out. Okay, exit that. Okay, next I'm going to click on plane number 5, and then again enter into a new sketch. Okay, accept that. And then we're going to select on plane number, or exit that sketch. Okay, and then we're going to select plane number 6, new sketch, and then just do a rectangle around that surface. So the warnings that are coming up is just a little problem with the auto surface, but hopefully we can resolve that. Okay, so now that that's done, we can now do some extrude cuts. So we'll go to features, we'll go extruded cut, select on that, go the opposite way, and accept. Okay, so you can see we've given it a real nice clean finish, and then we just repeat the process. So extrude cut again, make sure it goes the right way, accept. Okay, so one last plane to extrude. Okay, so now that that's done, we can basically extrude our circles into the body. So we could also do an extrude cut, and we can just select each of these sketches. Hopefully, maybe we can do them all at once, maybe not, and I might just set that to 5 millimeters, and that should be fine. Accept. Okay, so that worked, and then we just repeat the process on the next 2 holes. Okay, and then we can accept that too. Okay, last one to do. And accept. Okay, so it looks like one of the cylinders isn't quite long enough. So what we can do is just find that cylinder. Cylinder 2, we'll delete it. And we just say yep. Jump back into auto surface. We might try repair that one while we wait, but anyway, we'll jump back into VXmodel, and then we'll turn on that cylinder 2, and we just want to make sure that it's long enough, I guess, which it does look like, but maybe since we did that extrude cut, we chopped off the top of the cylinder. So why don't we just send that back over to SolidWorks. Okay, so we right click on that, and we go transfer to SolidWorks, and it just re-imports it back in. Okay, so we've re-imported that cylinder, and now we can remove it from the solid body. So we go insert, and we go to features, and we go to combine. So the main body is the auto surface, and we want to subtract these, and make sure you select subtract, and then OK. Okay, so we've now finished doing that, and then we can right click and just roll to the end, and then you can see that our cuts on the machine surfaces are back. One of the cuts failed, so that's probably because I deleted that cylinder. So we can easily just do another extrude cut on that and just make sure it goes the right way and accept. Okay, so that's now cut and your part has been completed. So we can just now turn off everything we don't want to see, so we can just turn off the visibility of the planes basically, and any sketches that there might be. Yep. And if we turn off the edges just to have a look at it, you can see we've got that part now into SolidWorks with properly machined cut holes. Yeah, ready to use and machine from.